The Steducentre, Grade 9, 2014, A&A Exam Review, Maths. Part 5. Question 10.1. Which triangle is congruent to triangle PQR? Is it ABC or FDE? Side angle side. SAS. If two pairs of sides of two triangles are equal in length and the included angle are equal in measurement, then the triangles are congruent. Side, side, side. If three pairs of sides of two triangles are equal in length, then the triangles are congruent. PQR is congruent to DEF. Question 10.2. In the given figure, P and T are points on a circle with the center M. N is a point on the chord PT such that MN is perpendicular to PT. You need to prove that PN is equal to NT. PM and TM are same. The radius of a circle is equal. MN is common. N1 is equal to N2, which is equal to 90 degrees. We are given that they are perpendicular. So, MNT is congruent to MNP. Angle MPN minus MTN is an isosceles triangle. So, NT is equal to NP, since these are congruent. Side, angle, side. Question 10.3. In the above diagram, AC is equal to DF, AB is equal to DE, and BF is equal to CE. 10.3.1. Prove that BC is equal to EF. 10.3.2. Prove that angle ABC is congruent to triangle DEF. 10.3.3. Why is angle B equal to angle E? 10.3.4. What is the relationship between AB and ED? 10.3.1. Prove that BC is equal to F. BF is equal to CE, which is given. BF plus FC is equal to FC plus CE. FC is common and BE is equal to CE, which is given. Therefore, BC is equal to FE. 10.3.2. Prove that triangle ABC is congruent to triangle DEF. BC is equal to FE. It's proven in 10.3.1. AC is equal to FD, which is given. AB is equal to ED, which is given. Therefore, ABC is congruent to DEF. Side, side, side. 10.3.3. Why is angle B equal to angle E? B is equal to E because they are corresponding angles of congruent triangles. 10.3.4. What is the relationship between AB and ED? AB is equal to ED, that is given. AB is parallel to ED. Question 10.4. In the figure, angle B is equal to angle C. AD is equal to 9 centimeters. AE is equal to 7 centimeters. And CE is equal to 21 centimeters. Prove that angle ABD is similar to angle ACE for 10.4.1 and calculate the length of BD for 10.4.2. There are specific rules you can use in order to prove congruency. Side, 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 side included angle side, angle side, angle, and angle, angle side, or right angle, hypotenuse side. Side, side, angle is not sufficient for congruency. It may make two different triangles. B is equal to C, which is given. A is equal to A, which is common. D1 is equal to E1, sum of the triangles, which is equal to 180 degrees. Therefore, ABD is similar to ACE, angle, angle, angle. Calculate the length of BD. AB over AC is equal to BD over CE, which is equal to AD over AE, proportional sides of similar triangles. BD over 21 is equal to 9 over 7, so BD is equal to 27. Question 11. In
parallelogram ABCD, AB is equal to 5 centimeters and AD is equal to 12 centimeters. BT is equal to 3 centimeters and AT is perpendicular to BC. Question 11.1. Calculate the length of AT. 11.2.1. The perimeter of the trapezium ADCT. And 11.2.2. The area of the trapezium ADCT. We need to consider using the Pythagoras theorem, where for any right angle with sides A and B and a hypotenuse h, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So h squared is equal to a squared plus b squared. So if we do the calculation, h squared is equal to a squared plus b squared, it will mean that 5 squared is equal to 3 squared plus a squared. Negative a squared is equal to minus 25 plus 9. Minus a squared is equal to negative 16. A is equal to the square root of 16, therefore a is equal to 4. For 11.2.1, the perimeter. Look at the question. ADCT. 12 plus 5 plus 12 minus 3 plus 5 means that 12 plus 5 plus 9 plus 5, which is equal to 30 centimeters. Remember that the perimeter is the distance around a 2D shape. 11.2.2. The sum of the areas of the two triangles is, of course, the area of the quadrilateral. If we can discover two lengths and an included angle for each triangle, we can use the area, which is equal to half xy sin z area equation to calculate the areas of the triangles. A is equal to half times 12 plus 9, close brackets, times 4, which is equal to half times 21 times 4, which is equal to half times 84, which is equal to 42. So, if we look at the formula, A is equal to half B1 plus B2 times H. Question 11.3. The circumference of the circle is 52 centimeters. Calculate the area of the circle correct to 2 decimal places. 52 divided by 3.14 pi is equal to 16.56 divided by 2, which is equal to 8.28. Your area is equal to 3.14 times 8.28 squared. So your area is equal to 215.27. So how did we find the radius of the circle when you are given the circumference? The circumference of the circle below is 232.36 feet. Find the radius using 3.4 for pi. So if you look at circumference, it's equal to 2 times pi times radius. So 232.36 times 2 times 3.14 times the radius. So your step 1, find the circumference and substitute. Step 2, divide by pi. Usually 3.14 is acceptable for pi. Step 3, divide by 2. Step 4, write down the units. So if we look at the circle, you can see that the area of the circle is equal to pi times the radius square. Question 11.4. The length of a rectangle is doubled. Write down the value of k if the area of the enlarged rectangle is equal to k times the area of the original rectangle. For 11.4, k will equal to 2. Question 12. Solve for x without using a calculator. Show the calculation steps. So 12.1, x is equal to brackets, the square root of 8 plus the square root of 2, close brackets, squared. 12.2, the square root of 1 over the square root of x is equal to 3. For 12.1, the square root of 8 plus the square root of 2 in brackets, you will have x is equal to the square root of 8 plus the square root of 2 times the square root of 8 plus the square root of 2. 8 plus the square root of 8 times the square root of 2 plus 2. 8 plus 2 times the square root of 2 times the square root of 2 plus 28 plus 8 plus 2 is equal to 18.
The square root of 1 over the square root of x is equal to 3 with 1 over the square root of x, which is equal to 3 squared. 1 over the square root of x, which is equal to 9. 1 over x, which is equal to 9 squared. 1 over x is equal to 81x, which is equal to 1 over 81.
Thank you for watching the Steducentre, turning ordinary learners into extraordinary leaders.